Design of control unit. So we know that there is the purpose of control unit. Control unit क्या है कि first it will rely on the program counter. Whatever address is there in the program counter उसको read करके memory में जाकर उस लोकेशन पे जो इंस्ट्रक्शन है उसको कॉपी करता है IR में. Then they will decode that instructions. Then whatever as per the instructions they will go and perform the read, write, and after at the end of this they will increment or update the program counter. This loop will be continued and this will be running forever. So they will be in the loop, always going to the program counter, copying into the IR, decode that, execute that instructions. It will not execute, but it will make in a format to be executable by ALU. So they will decode it, read the register, read the data from the memory, and then it will go and update the program counter. So that loop will be continued. Now let's talk about the design of control unit. Control unit there are two types of control unit. One is the hardware control unit and another is the microprogram control unit. Hardware control unit is made of gates, flip-flop, decoders. So it is faster because it is hardware. So once the clock cycle is coming, they will give the result. So it is faster, so performance is high. But as it is made by completely hardware, so it is very difficult to do the modification. Modification is not an easy. So if there is any mistakes, then we cannot correct the mistakes also. So correction of mistake is difficult, and if you wanted to add any features, so that is also not possible. It's not easy. So it's very difficult. But in the microprogram control unit, the instructions is programmed, so it is easy for modification, but it is slower. So it will be slower than the hardware control unit, but it is programmable and it is easy to modify. So that is the microprogram control unit. Now there is two things. One is RISC, that is called the reduced instruction set operation set computer, and another is the CISC, that is called the complex instructions set computer. So hardware always use the RISC, that is the reduced instruction set computer. Here instructions will be simple instructions, but the modification is difficult. Currently we are using Apple, iPod, mobiles, smartphone, and Nintendo OS. These are the examples. Maybe some other places also they are using, but still these are used in the Apple, iPod, mobiles and smartphones. Okay, now let's talk about the microprogram control unit. There are two types of microprogram. Okay, before going to there, let's discuss about the CISC. So CISC was invented by Intel, that is used in the AMD, Intel and VAX. So the instruction is complex, so it is a slower, but it reduces the number of instructions. So to complete one job, programmer has to write less instructions, less code to complete the job, because the most of complications are here. क्योंकि ये very complex, ये ज़्यादा काम कर सकता है. एक instructions can do the multiplication and copy also. So this is the type of thing. So we यहाँ पर हम ये program करके, and it is written in the ROM. So coding is there. So they will decode into the assembly language. They will written in the assembly language. Okay, there are two type of microprogram control. Before going there, let's discuss about the differences between RISC and CISC quickly. So RISC is called the reduced instruction cycle, and this is called the complex instruction cycle. It having the fixed size instructions, it is variable size instructions because it is programmable, so we can give any type, any size of the instructions. Code size is large. Now it's talking about our coding like programming. So because it is doing the small task, so our code will be the big one, but here our code will be the small, so number of instructions will be less. And instructions executed in a single clock cycle. Yes, one instruction will be executed in one clock cycle, but it will take more than one clock cycle to complete because this is a complex. And instructs fit in one words, okay, because it's a small and fixed size. Instructions are larger than the size of the one word. RISC is highly RISC is highly pipelined. CISC is less pipeline. Pipeline we will discuss. It requires more ROM. Yeah, because we have a large program, so it requires more ROM. But here our program is less, then it's required less ROM. Okay, I hope it is clear. Now let's talk about the two type of micro program is there. One is called the horizontal microprogram control unit, another is called the vertical microprogram control unit. What is that? Okay, let's discuss it, what it is saying. The microprogram control unit can be classified into two types based on the type of control word. Like control word is like what the instructions we are giving, that is stored into the control memory. Horizontal microprogram control unit and the vertical microprogram control unit. अब ये काम कैसे करता है? तो horizontal microprogram control unit में control signal are represented in the decoded library format, that is 1 bit for one control signal. तो अगर यहाँ पर 64 बिट का कंट्रोल सिग्नल है तो हमें 64 बिट भेजना पड़ेगा, बट यहाँ पर 64 बिट का अगर कंट्रोल सिग्नल है तो हमें 2 to the power 6 हमें 6 बिट ही चाहिए सिग्नल भेजने के लिए. इन वर्टिकल माइक्रो प्रोग्राम कंट्रोल यूनिट द कंट्रोल सिग्नल आर रिप्रेजेंटेड इन इकोडेड फॉर्मेट. नाउ अब हमें ये तो इकोडेड है तो हमें इसको डिकोड करना पड़ेगा, बट यहाँ पे हमें डिकोड करने की जरूरत नहीं है, डिकोड की जरूरत नहीं है. So this is the difference between horizontal microprogram control unit and vertical microprogram control unit. Now let's talk about how the hardware control unit is working. So this is the diagram. I think it's very common, everyone know about this. There is a 16 bit of IR register. The first 12 bit is the operand. It is here is operand, and this 3 bit is opcode, and this is the addressing mode. If it's a 0 then it's a direct, if it's 1 then it's indirect. Now what is happening, this opcode is decoded by the 3 into 8 decoder, and this opcode will decode and they will send the D0 to D7. So these are the instructions from here to here, and this is called on which operand they have to perform this operation. This is going to the combinational control unit where they will perform the logic. ये इस ऑपरेशंस जो D0 to D7 है उसको परफॉर्म करेगा. अब हम बात करते हैं टाइमिंग सिग्नल्स का. तो हमारे पास एक 4 बिट का सीक्वेंस काउंटर होता है. There are 3 inputs. One is increment, another is clear, another is clock signal. That clock signal is coming from that will be in this format. It is generating from the quads. So clock signal है clear, it will clear the program counter and it will increment the program counter. तो ये 4 बिट का सीक्वेंस काउंटर, और यहाँ पर एक डिकोडर है जो 4 बिट को 16 बिट में डिकोड करता है. तो बेस्ड ऑन द 4 बिट दे विल output will be the 16 bit from T0 to T15. ये सब combinedly it is going into the control unit. Now control unit will analyze this and then they will send the control signal. जो कंट्रोल सिग्नल की बात हम पिछले डायग्राम में यहाँ कर रहे थे, सॉरी हम यहाँ पे कंट्रोल सिग्नल की बात कर रहे थे। तो ये कंट्रोल सिग्नल है जो हमें एएलयू को पास जा रहा है, डेटा पाथ के पास जा रहा है। दिस इज द आईआर, बेस्ड ऑन द आईआर दे विल यूज आईआर एंड सीक्वेंस काउंटर and they will generate the control signal. Okay, आप ये अगर डायग्राम देखेंगे तो this is the same things. Decoder is there, one decoder is 4 into 16 decoder is here, conventional control logic and it is sending the control signal. यहाँ पे हमारे पास increment, clear and clock signals is coming to the sequence counter. I hope this is done for the control unit. Now next sessions maybe we will come with some of the MCQ. Can you check what is the EBCDIC? I will discuss this one. I already discussed the horizontal and vertical microprogram control unit. Thank you everyone. If you like this video and you think that it is helpful, please subscribe and share the video. Thank you.